So in the first part of the notes today, we will be taking our first look at R. By the end of this week, I want you to have as a goal to have R installed and be able to do some very basic computations and processes within R. So let's first talk just about what in the world is R, and then we'll talk a little bit about making basic calls and doing basic computations on R. Then we'll talk about the documentation and other kinds of features associated with the programming language. So, what is R? R is a high-level computer language. It's used for statistics, graphics. Now we would also add to this data science. It performs a variety of statistical methods. It also does data manipulation very well, very efficiently. It produces high quality graphics. You can do almost anything with R because it's actually very easy to write your own user-defined functions within R. So it's a highly adaptable and advanced programming language used almost entirely for statistical and data science computations. R was initially written by these two gentlemen, one named Robert Gentleman. Dr. Gentleman is from University of Auckland. He was a statistical computation researcher. This guy was more of a programmer. They both work within the Department of Statistics and worked together to develop this programming language. You might be able to guess why R is called R when you look at this. R is a free open source software package. It's maintained by a good number of contributors now. The core team is specifically of 17 programmers, made up of 17 programmers who really spend pretty much full-time jobs maintaining the R source code. There are contributors, though, in the hundreds. The official R page is given here. Take a look. Stop the video now. Take a look and just navigate around the page. Make sure you kind of make some sense of it. You can install R on Windows, Mac, or Linux. You can You're going to want to, in each case, install your base system. If you go to the R website and you follow the directions on the R website, that should work for you. I can provide help if you need it. In addition to this base system, there are some add-on packages. We will add these as we need them. But basically what you need to know about the packages right now is that they're a collection of examples and documentation and functions that do something very specific. So if you get really interested in, I don't know, mixed modeling, you might download LME4, which is a package that contains lots and lots of functions having to do with linear mixed modeling. The base system contains a lot of material for beginners. It often will suffice for some time. If you install additional packages, you need to be connected to the internet, and then you just install some, use a command such as this, install.packages, gplots. You might stop, make sure your installation of R is functional, and then try first install.packages gplots. Then you're going to be asked to select a mirror site. I recommend just choosing one near us. There are some in Texas, some in California. And finally, you need to load the package like this. You can use quotation marks for loading. You could also use the function word require rather than library. There are two equivalent functions that will make available contents of the package to a user. And either one is fine to use. You can go to the R website also for a complete list of contributed packages. So before you go on to the next slide, make sure you stop and make sure you can run without any error gplots, install.packages gplots, and then loading library gplots here. So there's several windows when you open up R. I'll There's a separate video where we'll take a look at this in just a moment. The R console is where your computations are performed, and it is the window typically in on the bottom left-hand side when you're using R Studio. An expression is put into the console and evaluated automatically. It's interactive, actually. It may respond by putting more results out on the console or creating a plot if you've created a graphical device, or something else may happen. This is what we call interactive mode within R. To get that last expression entered, you just use the up arrow. To get the last value of the last evaluated expression, you just type last value. You can just push escape anytime you're evaluating an expression and it stops execution. So let's make sure we understand this at a very basic level before we move on. We can enter the math expressions below here. Some of these are, I think almost all of these are self-evident. So run through all of these, go enter them into the console. So you'd enter what appears in red. Of course, that's the prompt, the little arrow there, so you don't ever enter that. That will just be your prompt on the console window. So you'd enter 5 modular 4 here, and this is modular arithmetic, so of course this is the remainder when you divide 5 by 4. This evaluates the natural log of 2, and so forth. Make sure you can get back all of these results. Okay, so we have objects and functions within R. You should consider these as the two basic types of formats within R. So everything could be thought of as an object, which often stores results, stores data, stores a graphical device, something like that, or functions which operate on objects. Okay, so what we typically do in an R session is we will create an object or objects, and then we'll take functions to operate on those objects. So think of it as, what if your function is x squared and your object is the number 2? If you operate x squared on the number 2, then of course you get 2 squared, which is 4. And it really is that simple. That's just a very simple functional version, and we'll do more complex things in this class. So we can assign an object a value, and we can use any of these syntactical devices here to make an assignment. An arrow can point either direction. Notice it can point to the right or the left, but whatever is being stored gets stored in that object being pointed to, in this case x. Or what I do most of the time, especially for quick programming objectives, I'll just use the equal sign, but then an x does need to be on the left-hand side of that expression. You can call any function. We'll see functions very soon. These functions will, we actually saw functions on the last page. Log, cosine, ceiling are all functions. Notice it here, our object was 2, and it produced an output based upon that function log. And so you use the function name on the left-hand side, like log, and then a list of the arguments that are inputs to the function. Each function has a set of formal arguments with some things that are default and some things that can be changed. It can be any subset of the complete argument list. We'll see some particular examples of this later on. When specifying a value for an argument, we always use an equal sign. We're too early on to worry about this too much right now. Beware that R is case sensitive. So if I had, say, done capital L-O-G, it would not have recognized that as the natural log function. It would have thought that was a new function and would not have been able to operate on the number 2. So let's say we want to find the mean of a set of numbers. So first we can assign the vectors, give it a clever name, X, and this C here just stands for column. So this just creates a column vector of these numbers. Notice when we print it out by just using the prompt here on the left-hand side and then printing out X, we could just do X or print parenthesis X, then we get that vector. Then we can compute the mean of X. So notice this 4.57 is the mean of those numbers. Let's say that we did capital X, because notice this is lowercase. It says X is not found because we have no capital X, we only have lowercase x. Let's say we want to sort a vector. So now we have a vector y. And notice in its original form it's not sorted in any direction. Well, we can run it through the function sort. And then we get from least to greatest. We have an option, so remember when specifying values for an argument we use an equal sign right there, that last little point. Well, here's one of our options within the sort function. We can have decreasing equal true or decreasing equal false. So here decreasing was assumed by default to be false, but on the next line here we've changed it to true. So if decreasing is true, the numbers should go from greatest to least. And that's exactly what happened. All right, so we'll do more with the console later, but we're going to move on to script next, and we'll stop there for now.